Beam design minimum requirements. So most of the time when we do the design of RCC elements, we always concentrate about what are the loads are coming to the structural element and then design accordingly. However, we need to take care of the codal provisions provided for minimum requirements. That means when you design a beam or column or any structural element, let's say the required reinforcement provided for that particular cross section is 100 mm square, maybe two 10 mm bars or two 12 mm bars. We cannot simply accept that two 12 mm bar is sufficient because the load is very less. Due to the several serviceability and strength criteria, the code has suggested the minimum requirement that need to be provided for the RCC section. What are those we can discuss in this chapter? It is very most important for structural design. The first thing is the effective depth. Depth of the section is normally fixed. How much depth is required based on two criteria. One is the strength criteria. That means how much bending moment is required, how much shear is required, and how much torsion is required. So based on that, we can provide the what is the total depth of the section required for the design or for the general for recommendations to the any length of the beam. The second check that need to be considered, even if you say based on the bending moment and shear force and torsion, let's say we need a depth 400 mm, good enough. But however, based on the length of the section, there is a serviceability criteria has been also provided by the code. We need to check what is the serviceability conditions is required. The several types of beams, simply supported beam, cantilever beam, continuous beam, there is a L by D ratio is provided, and we need to check based on the length what is the minimum depth is required for the particular length of the section. So these checks need to be required on top of the strength requirements. Okay, next one. Once we do the design, we'll make sure that the reinforcement we calculated based on the bending moment, shear force, and torsion should be maximum more than the AST minimum and less than the AST maximum. That means for given a particular cross section, so what code says minimum you need to provide this much steel and your steel should not be greater than AS equal to 0.04 BD, which is simply 4% of BD. And this is the AS by BD, B equal to this width of the section and D is the depth of the section, effective depth of the section. For minimum reinforcement, AS by BD equal to 0.85 Fy as per the clause has been referred this equation, and for the maximum should be this one. Why this minimum and maximum? As I said, let's say there is a small beam and there is no load is available. As per the load calculations, we may get very less required steel. But however, based on the cross-sectional dimensions and length of the member, so it may require to increase the required depth, and based on the cross-sectional depth, we need the minimum reinforcement as per the clause 26.5.1.1a, AS by BD equal to 0.8 by Fy. That means that is the minimum steel at least should be provided for the concrete beam. Similarly, 4% of the cross-sectional area should be provided for maximum steel. Means, let's say you have a heavy load, does not mean that you can provide more than 4% of the concrete. So that means if there is a heavy load, the steel required is more than 4%, you have to increase the depth of the section to make sure that this total required steel is less than the maximum allowable reinforcement suggested by the code book. Similarly, when your depth is greater than 750 mm, What code says, you need to provide the side reinforcement on top of whatever the reinforcement we are providing in the compression and tension zones. If the compression and tension zone we provide like this, okay. So what they say, the minimum when the depth of the section is greater than capital D is greater than 750, you need to provide a side face reinforcement. These reinforcements are called as a side face reinforcement. So we need to provide it. But however, if the same beam is subjected to the torsion, this depth, if it is greater than 450, even 450, then we need to provide this side face reinforcement. What code says, this side face reinforcement, the distance between this and this should not be greater than 300 mm. Okay, that's what the code has been suggesting here. How much reinforcement you need to provide side face reinforcement, which is 0.1% based on the code class recommended over here, class 26.5.1.3. So now the minimum rebar sizes need to be provided in the cross section. So there are classes 26.3.2a, 26.3.3a is referring about the horizontal reinforcement. What it says, when you provide the reinforcement, horizontal reinforcement like a 1, 2, 3, right? So these three reinforcement when you provide, make sure the maximum size of the rebar in that zone, the spacing between these two reinforcement, at least maximum size of the rebar. For example, this is the 10 mm and this is 20 mm. So that size minimum should be 20. You cannot actually put it like a 10 mm or something like that. The spacing between two bars should be 20 mm or 5 mm maximum of size of the aggregate. That means, for example, your aggregate size is 25 mm and plus 5, which is equal to 30 mm. So this spacing should be 30 mm now, because the bar is 20, but the second criteria is required minimum 30 mm. At the same time, maximum spacing between these two bars, the maximum spacing between any two bars should not be greater than 180 mm. So let's say you have a beam 300 mm width, 300 mm. You have only two bars are there, for example. In that case, these two bars distance should not be greater than 180 mm. If it is a greater than, because of this rule, you need to produce at least one more reinforcement in the middle. That's what the code says. Similarly, the vertical distance. Let's say when you have a two layers of the reinforcement, this is the one layer and this is the one layer. Two layers of the reinforcement. This distance should be 15 mm or 2/3 of the maximum size of the rebar. 2/3, for example, for 20, 2/3 of the 20 is somewhere around 12 mm plus. So minimum that much spacing should be required, or 15 mm spacing, or the maximum size of the bar. So that much spacing should be required as per the vertical distance. This is given in the clause number 26.3.2. Thank you.